Hello, my dear students. This is Atif Ahmed, your physics teacher, and today we are going to discuss stress strain curve. Before understanding the concept of stress strain curve, one should be very much clear about the true concept of tensile strain and tensile stress and how to produce stress within a solid. Then you will be able to understand this topic in a better way. Okay, so I would like to revise the main concept of tensile stress and tensile strain. Then I will come toward the main topic, that is stress strain curve. Okay, let's start. My dear students, we are taking an elastic solid in the form of a cylinder like this. Its original length is L naught, and we are applying a force on the cross-sectional area in this way, in this direction, or simply we are stretching this solid. So there will be some extension, the length will increase, and the increase in length is delta L. Now, what is tensile strain? It is nothing but it is a ratio between change in length delta L to the original length L naught. The change in length with respect to original length is known as tensile strain. So we simply say that strain in this case is equals to delta L over L naught. And strain have no unit. Why? Because length divided by length, meter will be cancelled by meter, so no unit. Okay, now what happened within a solid? When we apply a force and the body is extended, the particles of the solid were shifted from this position to this position. Now these particles want to go back to their original position, so they will apply a force in reverse direction. Simply it is a restoring force. So there will be a net force in this direction. This net force is equal and opposite to the applied force. Both have the same magnitude but direction is opposite. This internal force per unit area is stress. That is the true concept of stress. Okay, this internal force per unit area is stress. And one more thing which is very much important for understanding this concept. In this case, strain is producing stress. Strain is producing stress. How? We have extended this object, strain is produced. When the strain is produced, particles were shifted from this position to this position. That's why they are applying the force to go back to their original position. And that is the internal force. And this internal force per unit area is the stress. So, in this case, it is clear that strain is producing stress. Okay? So, remember this point. Now we are coming toward the main topic, that is stress strain curve. First of all, you should be clear about that. What is stress strain curve? Stress strain curve is simply a graph between stress and strain. And that graph describes the physical properties of the material, how a material will behave under the stress, or simply how a material will behave under a force. So the physical properties related to this will be examined, will be studied by using this graph. Okay, how we will get this graph? If we want to check the physical properties of a material, like we have a rod of iron and we are going to check the physical properties of this iron. So we will conduct a test that is called tensile test. By using a machine, we will put this object or this solid in the machine. Machine will grip this solid in this way. and it will produce strain in this rod and will measure the stress within a body. Then there is a computer screen attached with this machine that will show a graph between stress and strain. We will analyze the graph and understand the physical properties of this material. Okay, so I have written here, in order to study behavior of a material under stress, we use tensile test with the help of machine which strain the material at fixed linear rate and record the stress. So we obtain a stress strain graph like this from the screen of the machine. Okay, so I have mentioned the stress strain curve. It is a graph that represents how a material reacts to an applied force. This graph will explain that if you apply a force on the material, how this material will react to this force, up to what extent that material will endure the stress, and there will be no breaking. Okay, so now we are coming toward the main portion of this lecture, that is the graph, stress strain graph. My dear students, when we draw a graph, there are two variables. The first is the independent variable and the second one is the dependent variable. For example, we have an equation y is equals to 2x and we have to draw a graph for this equation. So we need 2 points, 1 point from the x and 1 point from the y, set of points. Okay, so we put the values of x here, 0, 1, 2, 3, 4. These values are not fixed. You may take values 2, 4, 8, 6 or something like this. Okay, but I am considering 0, 1, 2, 3, 4. Now what will be the value of y? Value of y is depending upon the value of x. If x is 0, the value of y will be 0. If x is 1, value of y will be 2. If x is 2, value of y is 4. If x is 3, value of y is 6. And if x is 4, value of y is 8. So values of y are depending upon the values of x. In this case, the values of x are independent, but values of y are dependent. Yeah, they are depending upon x. Okay, so these two variables, this one is independent variable and this one is dependent variable. Similar is the case here. In this case, strain is independent variable and we place independent variable along the x-axis, and stress is the dependent variable because stress is depending upon the strain. I have told you in the beginning that strain is producing the stress, so stress is depending upon the strain. Okay, strain is producing the stress, so stress is depending on the strain. So that's why we have taken the stress along the y-axis and the strain along the x-axis. So we have obtained a graph for the material. Now we are going to study this graph, how you will read this graph. My dear students, there are two regions and some points on this graph. So we have to remember these points and understand the region. There are two major regions in this graph. As you can see that the first region that is elastic region, and the second region that is plastic region. Elastic region is a region in which if we remove the stress on a deformed body, the body will regain its original shape, original length or original volume. And this is a region called plastic region. In this region, the deformed body, if we remove the stress on the deformed body, the body will not regain its original shape or volume or original length. Okay, so this region is called plastic region because we have studied that there are two types of deformations. Number one, elastic deformation and plastic deformation. In elastic deformation, the changes in the body are not permanent, they are temporary. When we remove the stress, the body will regain original shape, and in this region, in plastic deformation, the body will get permanently deformed and the body will not come back to its original position. Okay, so there are the two main regions. Number one, elastic region, and number two, plastic region. Body will regain original shape after removing the stress. the body will not able to regain original shape by removing stress. Okay, so these are the two major regions. Okay, now we have divided the elastic region in further two parts. The first one is OA and the second one is OB. In OA region, you can see that there is a straight line. So if there is a straight line and we are drawing the graph between the two quantities and there is a straight line, it indicates that there is direct relation between these two variables at these two quantities. Like we are drawing the graph between strain and stress, and this is a straight line. It means that straight line is telling us that there is a direct relation between stress and strain. What does it mean of direct relation? Okay, have a look. We have taken the strain along x-axis and stress along y-axis. Okay, let's suppose we have applied the strain of 1 unit and there is stress 5 Pascal. Okay, now if we double the strain, it is 2 unit, and the stress is also double, 10 Pascal. If we further increase up to 3 times, the stress will also 3 times, 15 Pascal. So there is a direct relation between strain and stress, and you will get the straight line like this. So I have roughly drawn. This is a straight line. Okay, and remember that in this case there is a constant ratio between stress and strain. Okay, there is a constant ratio. So it is clear that there is a straight line. A straight line is indicating that the stress and strain is directly proportional to each other, and there is a constant ratio between stress and strain. Okay, so the region OA is basically representing here the direct relation between stress and strain. Okay, and in this region, if we remove the stress, the body will regain its original shape, I have told you, and then we are coming toward the point A to B. So what is the point A? Point A is basically a point where a body can endure a maximum value of stress without losing a direct relation between stress and strain. Okay, now if we further increase the strain in the body, the stress will increase, but remember that after this point there will be no direct relation between stress and strain. You are increasing the strain, there will be some increase in the stress, but remember that the ratio between stress and strain will not be same as we have earlier. Okay, so the ratio between stress and strain will not be same. In the region from O to A, the ratio between stress and strain was same, but in the region from A to B, there will be no same ratio between stress and strain. So that is the difference. So after crossing the point A, no direct relation between stress and strain. Okay, so here is another point B, and that point is called elastic limit. That is the maximum value of stress. Under this stress, the body is still able to regain its original shape. So from point O to point B, the body is able to regain its original shape, length or volume. Okay, this point is also known as yield point. Okay, now if we further increase the strain, there will be some stress in the body, and there is another point C. Some materials have a greater yield point is B, and there are some material which have the lower yield point, that is C. So I have mentioned C here, that is another yield point called lower yield point. If you further increase the strain, the stress will increase and the body will start permanently de-shaping. Now there will be permanent changes in the body. If you remove the stress, the body will not able to regain its original shape or length or volume. Okay, now we are further increasing the strain and the stress is increasing. We are increasing further strain, stress is increasing, then again a point will come. That point is called ultimate tensile strength. Up to that point, a material can endure a maximum value of stress without waking and without fracturing. And after that point, if you further increase the strain in the body will start fracturing. There will be propagation of fractures inside the body, and the cross sectional area of the body will start decreasing, and a point will come, the body will completely break, and that point E. Okay, E is the point where the body will be break, and this is called necking point, or the second is name is fracture point. Okay, so in this way we can analyze this graph. I have told you that from region O to A there is a direct relation between strain and stress, and region from A to B there is no direct relation between stress and strain. If you further increase the strain, the stress will increase, but there will be not the constant ratio between stress and strain. And after crossing the point B, if you increase the strain, the stress will also increase, but the body will start permanently de-shaping. Now the body is not able to regain original shape, length, and you further increasing the strain, further increasing, a point will come. Up to that point the body can bear the maximum value of stress without breaking. Okay, and this point is called ultimate tensile strength. If you further increase the strain in the body will start propagating fractures inside, and the cross section area will decrease, and finally it will break at point E, which is called necking point or fracture point. So this is the main concept of our graph. So I have provided the notes for you. You can also understand as well as learn how to write in the paper. So if you feel any difficulty in this lecture, you may ask in the comment section, and if you like this video, please subscribe my channel.